Do you know all the different ways to describe a plane? I think it makes the most sense to start with the vector equation of a plane. A vector n that's normal to the plane tells you about how the plane is tilted. Then any vector that lies in the plane is orthogonal to n. Vectors are orthogonal when their dot product equals 0. Now how does this vector equation relate to what you probably saw in a college algebra class? Well, let's put the coordinates back in and actually perform this dot product. We just multiply the corresponding entries in the two vectors and then add those products. We'll distribute A, B, and C, but let's focus on the last terms that you get. We're going to collect these together and rename this D. Then the overall result of distributing can be written as AX plus BY plus CZ plus D equals 0. If you subtract D to the other side, you'll see that the left side is the dot product of the normal vector n with the position vector of a general point Q that lives on the plane. Thus all points Q that live on the plane must satisfy this equation. So if we think about a point Q and its position vector being interchangeable for a moment, then the plane is all points Q whose dot product with the normal vector is negative D. The original expression for negative D is just the dot product of the normal vector with the position vector of the point P that lived on the plane. So if initially you only knew a normal vector n to the plane and a point P on the plane, then any general point Q on the plane has the same dot product with n as P does. Let's divide both sides by the square of the length of the normal vector and scale n by this quantity. The resulting vector is known as the projection along n. So the plane is all points Q whose projection along n is the same as P's projection along n. Let's take a little break from the algebra and try to visualize what's going on. The projection of P along n is just the base of this right triangle. So if you project a different point Q along n, you get a right triangle with the same base. So if all points on the plane project along the normal vector in the same way, what can that tell us? Let's measure the length of both sides of this equation. Remember n dot p was negative d, so this has the same absolute value as d. Thus all points Q on the plane have the same projection along n, and the length of that projection is the absolute value of d over the magnitude of n. And this length is the shortest distance from the plane to the origin.